Alright, quick review from yesterday. Here's a polynomial. It's written in standard form. Standard form means it starts from the highest power term and works its way down to the constant. So x squared plus 7x, that's to the first, minus 18, and they don't have an x on there. Okay, that's your constant. There's three terms, so it's a trinomial. The degree, the highest exponent you see is 2, so that's why it's quadratic. Okay, it would cross the x-axis twice, okay, because it's a parabola, okay, or could cross it twice if it has two real solutions. Then we talked about how we would find those x-intercepts. Well, you guys said plug in 0 for y, and then in order to solve, you guys like to factor, which is good. You got these for your x values, and then these would be your x-intercepts. Okay, that's kind of what we did in class yesterday. And then the real big thing that I wanted you to kind of make a connection on was actually at this step, these are called the solutions or the zeros of the polynomial. Does anybody remember why these are called the zeros of the polynomial?
Because they make zero.
Awesome. Yeah, if you plug this x value in, you'll get a 0 for y. So they're called the zeros. Okay? -9 is a 0, and 2 is a 0. Other numbers would not be zeros. You could try any other number you want to, and you won't get 0 for y. So these are the only two zeros of that polynomial. Does that make some sense? Okay? And then I also wanted you to notice that when something is written in standard form, it's really not easy to tell what the zeros are. But if something was written in factored form like this, you know, if this said y equals parentheses x plus 9, x minus 2, is it pretty easy to tell what the zeros are if you saw factored form? Sure, right? What value of x makes this factor equal to 0? Or in other words, what plus 9 is equal to 0? -9. What minus 2 is equal to 0? +2. So if you see the factors, the zeros are easy. And then the other way around, if you know the zeros, shouldn't you also then know the factors? If -9 is a 0, then x plus 9 is a factor. If 2 is a 0, then x minus 2 is a factor. So the connection, if you know these, you know these. If you know these, you know those. Yeah? No? Any questions on that? Okay, so I wanted you to start to look at just a couple of practice problems involving that idea. Where the directions say, find all the zeros. And what's nice about this? It's already in factored form, yeah. Okay, so when you look at that, you can say, okay, well, what x values would be my zeros? What x values would make y equal 0?
1/2.
1/2?
And 5.
And 5, right? Okay. And if you can't do that mentally in your head, okay, what do you do with each factor to figure that out? Set it equal to 0, right? 2x minus 1 equals 0. Add 1 to both sides. Divide by 2, and you get 1/2. So 1/2 is a 0. If I plug 1/2 in for x, I will get a 0 for y. Right?
Yep.
Okay? Same thing with 5. If I plug in a 5 for x, I would get 0 for y. Okay? Do you guys have any questions about finding the zeros when things are given to you in factored form? Are there any questions? Let's try this one. This is about as difficult as they're going to. Well, there's a couple here. Okay? This requires a little bit of work. If you want to find the zeros of this polynomial, okay, I can probably do one mentally. The other ones I'm going to have to do a little more thinking on. Okay? Or maybe show my work even. Okay? So let's do that. Let's find the zeros for this guy. Tell me what to do. Or tell me what you would know.
Well, the first one would be just x equals half.
First one's half again, right? Just similar to the one I just showed you. If I set 2x minus 1 equal to 0, add 1, divide by 2, and I get x equals 1/2. Okay? What about the next one?
Square root of 3.
Square root of what?
-3.
Square root of -3, because you have to subtract 3 from both sides. And what happened? What do you get when you square root a -3?
I.
Plus or minus I radical 3. So there's 2 more zeros. Okay? And then, how about the last one?
Square root of 5 over 2.
Add 5, divide by 2,
And
Square root.
square root, plus or minus the square root of 5 over the square root of 2, multiply by radical 2 over radical 2, and you get
10 over 2.
radical
10.
10 over a regular 2. Okay? So how many zeros did that polynomial actually have? 5 of them. 1, 2, 3, 4, 5. Okay? If you were to graph this polynomial on Desmos, how many times would you see it cross the x-axis? Careful.
3 times.
3 times. You'd see it cross here. You'd see it cross at positive root 10 over 2. You see it cross at negative root 10 over 2. But why would you not see these?
Because it's imaginary.
They're imaginary numbers. Okay? Those are complex numbers. Those don't show up on the real number plane. Okay? So it has 5 zeros, but only 3 of them are real. So if you were to graph it, you would only see that graph cross the x-axis on those 3 real numbers. Okay? Alright, so when something is in factored form, do you feel like you can find the zeros okay? You're okay on that? So then they switched it around. And by the way, if you haven't done any of these, I think if you just do the odd ones, that's enough. If you do more than that, that's fine. But if you do 1, 3, 5, 7, okay, that's pretty good. So then they switch it around. Okay? They say write a polynomial function of least degree with integral coefficients that has the given zeros. So they want you to write the polynomial, the equation, y equals whatever, of least degree, so that means don't make it have a degree of 10 or something when you don't need that to be 1. With integer coefficients, so that means no fractions. Okay? That has the given zeros. So, for instance, they give you the zeros of 3, 2, and negative 2. Where's my... That's nice. So I give you the zeros, you got to come up with the polynomial. How would you start it?
X minus 3.
Write it in what form? Factored form.
So x minus 3.
X minus 3, x minus 2, x plus 2. Yeah?
Yep.
Okay? Now, not bad practice to multiply that out. Okay, I don't know that you necessarily have to do that on all of them. Okay, that might get a little bit redundant, but maybe on a couple of them, practice that. When you multiply 3 things together, multiply the first 2 first. So x squared minus 2x minus 3x makes minus 5x plus 6. So I multiplied those 2 together and got this answer. Then I'm going to take this answer times this. So I distribute the x squared, that would be x cubed plus 2x squared. Then I distribute the negative 5x, so negative 5x squared minus 10x. Then I distribute the 6 plus 6x plus 12. Then I combine all my like terms. X cubed minus 3x squared minus 4x plus 12. So here's the polynomial that has zeros of 3, 2, and negative 2. So if I give you the zeros, you come up with a polynomial. Yes? No? Questions? Figured I'd use red for Red Sox today. Is that all right? Guys are quiet this morning. Is this simple? So look at some of the other ones that you're going to be asked to do. Okay. Number 10, there's 4 of them. A little bit tougher when you got to multiply. 11, there's just 3 of them. Look and think. Would you have any questions about any of these? Here are the zeros.
How would you do 13?
How would you do 13? Why?
With the fraction.
With the fraction. Okay, great question. Okay, he's saying when you see a fraction as a 0, okay, how would you do that?
It would have to be the coefficient.
Well, if x has to equal 5/3,
You just multiply.
multiply both sides by 3, and then subtract 5. And you get 3x minus 5 equals 0, right? So therefore, one of the factors is simply 3x minus 5. It's like working backwards, you know, from setting the factor equal to 0 to get your answer. Well, now, here's your answer. Let's get it set equal to 0. So multiply both sides by 3 to get rid of the 3, then subtract the 5. Does that make sense?
Yeah.
Good question. Any others that look a little difficult? Okay? And then we kind of put it all together on the last chunk of problems. It says, find all the zeros by factoring. Okay, find all the zeros by factoring. I'm going to do 18 for you. X to the 4th plus x squared minus 12. Find all the zeros. X to the 4th plus x squared minus 12. So find all the zeros. Okay? Well, to find all the zeros, you
Set the y equal to 0.
Yep, set y equal to 0. And then it said find them all by factoring, right? This is a pretty easy factor. It's a trinomial. There is no greatest common factor. What times what gives me x to the 4th. X squared and x squared. What two numbers multiply to negative 12, but add to 1?
4, negative 3.
Positive 4, negative 3. Can I factor it any further? No. How do I find the zeros? No, if I multiply it out, I get back here.
Wait, can't you simplify x more?
X squared plus 4.
Set them equal to 0. And no, I can't simplify that more because it's a sum of two perfect squares. If that was a difference of two perfect squares, I could factor in more, but it's not. It's a sum.
I'm talking about like if you square root like the x and then the 4. Or can you not do that?
You can't square it in individual terms.
Okay.
Yeah, you can't factor that any further.
Okay.
If it was minus, you could factor it further. If that said x squared minus 4, that would become x plus 2, x minus 2.
Okay. Got it.
Remember that one?
Yeah.
Okay. So now, set both factors equal to 0. Subtract 4. What's the square root of negative 4?
2i.
2i. So x equals positive or negative 2i. X squared equals 3. And then square root both sides. Positive or negative radical 3. Can't really do anything with it, so just leave it as radical 3. So there's all your zeros. Positive, negative 2i, positive, negative, radical 3. Okay? Any questions on that? Okay. Why don't you guys try, if you've already done some from the first two groups, or you feel that's really simple, really easy, okay? That's fine. Jump down and just do 15 through 20. I guess I've done 18 already for you, so. Okay? That should be a little bit of practice here, just finding the zeros using your factoring scheme. Okay?
Oh, if you just do it like that.